session on ANSYS Workbench tutorials. In this session, we are going to analyze the Shackle pin for its thermal analysis. We will start by double-clicking on Steady State Thermal. We'll first go to Engineering Data. I'll use two materials for the analysis. One is alloy steel. The isotropic thermal conductivity for alloy steel is 52 watt per meter degree Celsius. Next, I will go to Engineering Data Sources, General Materials. I will also add stainless steel as a second material for the analysis purpose. You can see here there are two materials now, alloy steel and stainless steel. As far as structural steel goes, it is the default material of ANSYS. So I haven't added it, but it gets added by default. Next, I'll go to Project and update project. Next, I'll go to Geometry and right click. And I'll import the Shackle. Next, I'll go to Model and double click on it. In the previous sessions, you must have seen that I have already done the analysis of Shackle separately. Here I am going to analyze the pin of the Shackle. First, I'll go to Geometry and select the Shackle pin, and I'll allocate the material as alloy steel. For the Shackle also, I'll insert the material as alloy steel. Next, I'll go to Mesh and I'll go to Sizing and change the sizing to Fine and update. Next, I'll go to Steady State Thermal and I'm going to insert temperature. In the Geometry, I'll go to the Shackle pin and suppress the body such that I can apply the temperature on this inner portion. We have already discussed before that the maximum temperature that the Shackle can be subjected to is 204 degrees Celsius. Also, I will insert convection. I will unsuppress the Shackle pin, and in the convection, I am going to select the entire bodies. I'll give the film coefficient as 0.032, which is the film coefficient of air, and the ambient temperature, let it be as 22 degrees Celsius itself. I'm not changing it. Next, I'll go to solution and I'm going to insert thermal temperature. This is for all the bodies. I will also insert thermal total heat flux. Next, I'll insert thermal temperature and I'll change this geometry to only the Shackle pin. Also, I'll go to solution and insert thermal total heat flux. Again, I'll select the pin alone such that I can get the results for the pin. You may also see the directional heat flux for the Shackle pin. This direction is x-axis. Now I'll go to solution and solve. We'll first see the results for temperature. You can see here the maximum value of temperature is 218.96 degrees Celsius and the minimum temperature is 22 degrees Celsius over the entire Shackle. Next, we'll see the total heat flux over the body. The value is 12.752 watt per mm square for the entire body, where the color is red, and it is 2.0244 into 10 raised to minus 8 watt per mm square for the portion where it is this blue color. You can again animate and check the result. If you want, you can also click on max min such that you can get the value of maximum and minimum temperature over the body. And if you don't want to see the results, you can just click on it once again. If you don't want to see the meshing on this body, you can come to edges and click on no wireframe such that the meshes do not appear on the body. Now we'll see the temperature over the shackle pin. You can see here there is a proper distribution of temperature over the shackle pin. You can animate and check the result. The maximum value of temperature is 218.96 degrees Celsius. Let's see where the value is max and min. And the minimum value is 22.001 degrees Celsius where the color is blue. You can see the total heat flux over the body. At certain places it is more and at certain places it is less. The value of maximum heat flux over the pin is 7.4752 watt per mm square and the minimum value is 2.825 × 10⁻⁵ watt per mm square. You can read the results from here for the rest of the values. If you want to see the value at a particular color, you can just click on probe and go to that particular color, you will see the value. For example, this yellow color is 6.2894. If you want to see the color green, you can see this 2.4996 over here. From this zone, we have got the value. If you don't want to see these values, you can just right click here and delete all. Also, if you want to see the directional heat flux over the pin, this is the result. You can animate and see the result here. The directional heat flux along the x-axis has a maximum value of 7.4115 watt per mm square and the minimum value is -7.084 watt per mm square. So this is as far as alloy steel is concerned. Let's change the material to stainless steel and let's see what is the result now. See to it that you change the material of both, because if you don't change the material of one, it will not work properly. Also, generally the D-shackle with the pin is made of the same material. It doesn't happen that both of them are of different material. Let's solve once again. Now let's check the result. The temperature value for stainless steel, the maximum value is 237.34 degrees Celsius and the minimum value is 7.13 degrees Celsius. You can again animate and check the result. Now next we will see the total heat flux over the D-shackle along with the pin. The value is 5.6048 watt per mm square. Minimum value is 1.433 × 10⁻⁻10 watt per mm square. If you want, you can check this result in animated form. Now let's see the temperature distribution over the pin. The maximum value is 237.34 degrees Celsius and the minimum value is 7.13 degrees Celsius. Let's animate. The total heat flux is 3.21 watt per mm square. This is the maximum value and the minimum value is 7.62 × 10⁻⁸ watt per mm square. Also, we can see the directional heat flux for the pin. The maximum value is 3.1793 watt per mm square and the minimum value is -2.8841 watt per mm square. You can see where the value is maximum and minimum over the pin. So this is a comparative analysis using two different materials for the D-shackle pin. With this, I end the session. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.